Hi friends, this is Unit 5 Lesson 5 and Unit 5 Lesson 6. Loops explore and then loops investigate. So let's imagine you've got a little robot, my little triangle down here, and we know that we have a command, move forward, that will move the robot one space forward. So if we wanted to move it up to the purple box, we would say move forward, then move forward, then move forward, then move forward. So we would have to say this 4 times. But we can simplify this by using a loop. A loop says do this same thing over and over and over and over until something. So we are going to need to incorporate some of the other things we've talked about, like booleans, variables, and sometimes lists, in order to make this work. So when we have a while loop, it keeps running over and over and over until whatever the check is no longer true. Well, true and false are our 2 booleans. So we know a boolean value is what's going to determine if we keep running or if we exit. So check out this code here. This says we initiate a variable steps and set it to 0. Then we say while steps is less than 4, move forward. Steps adds a value. So what this plus plus means is we're going to increase steps, basically. It just counts it one more. It's called a counting variable, and it literally counts how many times the loop runs. So while steps is less than 4, move forward and add 1 to steps. So, okay, we start off with steps equal to 0. And then we're going to check this. While steps is less than 4. Here we go. Here's round 1. While steps is less than 4, we should move forward and add 1 to steps. So right now, steps is 0. So it's true. And we'll move forward. There we go. And then we'll add 1 to steps. So steps now becomes 1. Well, it says we keep doing it over and over until we get a false. So we're going to do it again. So while steps is less than 4, yep, 1 is less than 4. So we're true. Move forward and add 1 to steps. So we move forward and we add 1 to steps. And then we go again. So while steps is less than 4, yep, 2 is less than 4, so that's true. Move forward and then add 1. So now steps is 3. Well, while steps is less than 4, yep, 3 is less than 4, so it's true. Move forward and add 1. And there we go. Now, while steps is less than 4, 4 is not less than 4. So this evaluates to false, and we stop. So we exit the loop. Here's another example. Something is missing from this code that was in the other code. This says, while steps is less than, we initiate the variable steps at 0. While steps is less than 4, move forward. Well, we never advance steps, so it just moves forward until it flies off the board. It flies off the board because we never advanced our counting variable. This would be called an infinite loop. An infinite loop has no way to stop it, and that's what happens when you forget your counting variable. If you write an infinite loop, your computer will just spin forever and ever and ever. It might crash your browser. Control-C a lot of times is a good exit. So let's introduce a new command. We're going to call this turn right. So here's our, I can't figure out where to put my face. There we go. So here's our next program. This says we initiate the variable steps. While steps is less than 4, move forward, turn right, and then add 1. Okay, so we're starting off, we're starting off with steps equal to 0. 0 is less than 4, so we should move forward and turn right. So we moved forward and we turned right. And then we should add 1 to steps. So steps is now equal to 1. Now, while steps is less than 4, move forward, turn right. Okay? Add 1. Steps is now equal to 2. Do it again. Is 2 less than 4? Yes. Now we add 1. Now we're at 3. Is 3 less than 4? Yes. So we move forward, turn right, and we add 1. Now we're at 4. Is 4 less than 4? No. So we exit the loop. So our position is this purple box over here. So we have several important parts to our while loop. The first is we need to initiate a counting variable and set it to some initial value. Most of the time it's 0. Then we need a Boolean that checks the condition of the counting variable. And that is what will let us exit the loop eventually. When this evaluates to false, then we know we're done. Then finally, we need the statement that says whatever we want to do, but we also need the statement which increases or decreases that variable, because we need to change the counting variable so that we can get out of the loop. Otherwise, we end up with an infinite loop that goes forever, ties up your computer, or crashes your browser. So here's our game board. You should have one on your assignment as well. So what we're going to do is you're going to see the code and you're going to predict where on the bingo board this robot is going to end up. So we initiate variable steps is equal to 0. While steps is less than 3, move forward, turn right, move forward, turn left, and then add 1 to steps. So pause the video and see if you can figure out where it will end up. Okay, let's watch. So initially, oops, I started too soon. Okay, initially, steps is equal to 0. 0 is less than 3. We're good. Move forward. Turn right. Move forward. Turn left. And add 1 to steps. Steps is now 1. Evaluate again. 1's less than 3, so move forward. Turn right. Move forward. Turn left. And add 1 to steps. Evaluate again. 2 is less than 3, so move forward. Turn right. Move forward, turn left, add 1 to steps. So 3 is not less than 3, so this is where we finish. G2. G2 is where we finish. Another type of loop is called a for loop. And a for loop is going to combine all these 3 parts into one statement. So in our while loop, we initiated our counting variable. Then we wrote the Boolean. So while this is true, move forward and add 1 to our variable steps. If we want to write it as a for loop, we get that all together into one statement. For a variable initiated as I beginning at 0, while I is less than 4, adding 1 to I every time. So all 3 parts come in order: initiate the variable, give the Boolean, add 1 every time. So our for loop functions pretty much exactly the same. It's just condensed. So our variable initiation is present, our Boolean is present, and our variable advancement is also present. I is a very common counting variable. J is a common counting variable. K is a common counting variable. N can be a common counting variable. So you might, oops, I didn't mean to press that. You might choose to keep track of I on a piece of paper while you're moving this around. Go ahead and predict where will the robot land on your slides. Pause the video, give it a shot. All right, well, for variable I initiated at 0, while I is less than 3, adding 1 every time, move forward, turn right, move forward, turn left. So this is going to look really similar to the one before. So there's our first iteration. Now we add 1 to the variable I. and we do it again. Then we add 1 to the letter I, and we do it again. I is still less than 3, so when we add 1 to the variable I, well, 3 is not less than 3, so we exit the loop. Let's look at another example. Here's a new program for variable I initiated at 0 while I is less than or equal to 2, adding 1 every time, move forward, turn right, move forward. So pause the video and see if you can figure out where it's going to end up. Okay, let's try it. Move forward, turn right, move forward. And then we advance the variable I. And we go again. Move forward, turn right, move forward. We advance the variable I. Well, 2 is less than or equal to 2, because it's equal, right? We had less than or equal this time. So we do it again. Move my face over there. Move forward, turn right, move forward. Now the variable I is equal to 3, which is not less than or equal to 2, so this is where we end. Okay, our next program for variable I initiated at 0, I is less than 2, adding 1 every time, move forward, turn left, move forward, move forward. All right, so starting with I is 0, move forward, turn left, move forward, advance the variable I. Okay, well, 1 is less than 2, so go again. Move forward, turn left, move forward. Get 2 now. Well, 2 is not less than 2, so we're done. And this is where we end. So something to make it more difficult. We have some new commands. Can move, and we can put in a different input. Can move left, can move right, can move forward, can move backward. Out of these different commands, we get a Boolean variable, either true or false. If you can move, you get true. If you can't, you get false. So the big gray circles are barriers, so you can't cross them. And the walls, obviously, you shouldn't be able to cross them. So let's try this one. In this position, the robot can move forward, so we would get true. Our Boolean output would be true. In this position, can move right would evaluate to true because we can move to the right. Can move left would evaluate to false because the barrier is in the way. But we can move backwards, so that would evaluate to true. In this position, can move forward would be true because we can't, there's nothing there. Can move right would be true because there's nothing there. Can move left would be false because the wall is there. And can move backwards would be false because the barrier is there. So let's try this program and see if we can figure out where the robot will end up. So for variable I is initiated at 0, while I is less than 3, adding 1 every time. If you can move right, turn right, then move forward. And this is outside of the if statement. Turn left. If can move forward, move forward. So pause the video and see if you can figure out where he's going to end up. All right, let's see. So for my first iteration, can move right returns true. So I turn right and move forward. Then I should turn left, but I couldn't move forward, so I did not move forward again. So let's watch that again. I made it play too fast. If we can move right, turn right, and then move forward. So I can move right, so turn right and move forward. Then turn left, and if you can move forward, but I can't. Now, I is equal to 1. Next iteration. If I can move right, turn right, move forward, then turn left. If I can move forward, move forward. Now I'm at 2. Okay? If I can move right, I can't. Then I turned left, and then if I can move forward, but I can't. So my end position is right there. Okay. Here's my last one. For variable I initiated at 0, while I is less than 4, adding 1 every time. If you can move forward, then turn left. If you can move forward, then turn right. Pause the video and see if you can figure out where he'll end up. Okay, so if I can move forward. So I was here, then I turned left. Then if I can move forward, I could, and then I turned right. Then round 2, if I can move forward, I did. Then I turned left. If I can move forward, so now I'm facing this way. If I can move forward, couldn't do it. So I turned back to the right. Now, I is equal to 3. So if I can move forward, then turn left. If I can move forward, then turn right. Then for round 4, if I can move forward, couldn't do it. So I turned left. If I can move forward, then I turned right. So here's my ending place for round 4. All right, so we're not going to set up a board. Just kidding. But here are all of our different commands. And importantly, for our for loop, our setup is initiate the counting variable at its whatever it's going to start at. While whatever your counting variable is, here's your Boolean. And then adding 1 every time, or you could do subtracting 1 every time. Our key takeaways is that our while loop uses a Boolean and repeatedly runs a block of code. If the Boolean evaluates to true, it will keep running until it becomes false. Our for loop is going to condense that. It still uses a Boolean, it still uses a counting variable, and it continues to do something until the Boolean becomes false. Now, what you are going to do, you can watch this video. What you are going to do is next, the second part of the lesson, you are going to explore different while loops inside apps. So 2 things to keep an eye out for. Iterations is the portion that you do over and over until a condition is met. And an infinite loop is when the ending condition never happens. So the Boolean never becomes false. So you are going to lesson 6, level 2. You're exploring the app. Then there are questions to answer. On level 3, same deal. Level 4, same deal. So go ahead and get started on those. And I will see you next time for lessons 7 and 8.